Open the GitHub link. You can download the app by clicking on this link or go to the Play Store on mobile and search Nav2 Mission Planner from Bot4 Robotics and install it. I have already installed the app. To work with Nav2 Mission Planner, you need a robot running on ROS2 Jazzy or later, which is already able to navigate through poses with the Nav2 stack. Here I am using a TurtleBot4 simulation, which is already set up in my system. If you want to try on TurtleBot, you can install it from here. You need to have these additional two launch files. The first is the mapping launch file, which will launch Nav2 bringup and SLAM toolbox for mapping or any of your mapping algorithms. The second launch file is for navigation, which should launch Nav2 bringup and the localization node. You can start with using the example templates below. I am creating those launch files in the TurtleBot4 navigation package. As you can see, there are already 3 launch files in this package. For mapping, we should launch Nav2 and SLAM launch files, and for navigation, we will launch Nav2 and localization. This is exactly what our template wrappers do with a single launch file. Create mapping.launch.py and paste the copied template. From this, we have to replace some package name placeholders that contain the actual configs of your robot. Copy the placeholder, find that in the copied code and replace it with your actual package name. As per the template, the file name is slam.yaml inside the config folder. Replace the package name with your package name. If needed, change the folder and file names too. As you can see, the slam.yaml file is in config folder of TurtleBot4 navigation package. Next is for the nav2 params file. Replace the package name, folder name, and file name as per your robot's location. Now we will create the navigation launch file. Copy and paste the template code and replace these placeholders. Replace where nav2 and localization params are located, which is same TurtleBot4 navigation package. Another is where maps are located. We can see all the maps are in Maps folder inside TurtleBot4 navigation package. Replace package and folder names here. Now your robot has the 2 required launch files for mapping and navigation. Next, your robot requires a supporting package to communicate with Mission Planner app. First, we need to uninstall any ROS Bridge server packages installed, as it may be updated or features removed which directly affect our app. Install our forked repo maintained by us. Next, follow these instructions to create the Mission Planner workspace. Source the Mission Planner, or you can add the source permanently using the .bash rc file. Now let's run TurtleBot simulation and the Mission Planner node to set up the robot in the app. Open a few terminals and source ROS2 Jazzy, Mission Planner workspace, and TurtleBot4 workspace. Source the same for remaining terminals. Now launch TurtleBot4 simulation in one terminal. and Mission Planner in another terminal. For Mission Planner, we need to pass the raw image topic of the camera. Let's find the topic of TurtleBot4. We can also launch with a camera topic parameter, or if no camera is available, skip it. Now open the Mission Planner app on your Android device. Sign up with your Google account. The first time, you will see the setup guide URL. You can also use the manual icon to get this repo link. Next, to connect to the robot, you need the IP address of the robot. Let's find the IP address. Now in the app, give a name to the robot, enter IP and port, and click on Connect. Here in the Robot Setup Wizard for the first time, enter the camera topic. By default, it is /out/compressed. If you pass the topic in the launch file, check that the topic is available, then enter it here. Enable the camera and give permissions to save captured images. Modify or leave the default ODOM and scan topics. Next, you can change the command velocity topic type, stamped or unstamped, and set up speed limits of the robot. Enter the location of the mapping launch file in the recommended format. Created before in the TurtleBot4 navigation package with the file name mapping. You can also pass arguments to that launch file. As we are using simulation, we need to pass useSimTime true. Pass it here. You can add any number of parameters here that will be passed when clicking the Start Mapping button. Enter the maps location, package name /maps folder. Change or modify the ODOM topic. You can also modify these later in settings. Now do the same for the navigation launch file parameters and topics. In the Teleop screen, you can see the camera image, control using the on-screen joystick, or capture images. You can do mapping and navigation here. You can see the list of maps available in the given path. In the settings screen, you can edit your robot configurations, previously edited in the wizard. You can also use a hardware joystick connected via Bluetooth to the PC or robot. Then you can directly use the joystick like others by launching Joy and Teleop Twist Joy nodes, which I have launched using launch file. You can see the captured images in your gallery. In the mapping screen, click to start mapping and move the robot around. Then you can stop mapping by clicking the stop button or save the map with the save button. Enter a map name and click save. Once saved, you can see the map in the workspace Install Package Maps folder. Click Stop to stop mapping. In the navigation screen, click Refresh to get the latest maps. You can see the saved test map. You can slide left to delete it. Now let's select the map and start navigation. Wait for the map to load. Select Pose Estimate button. Long press on the map and move around to place the marker. Then select an angle to publish Pose Estimate. You can save reusable locations by selecting the Bookmarks option. Long press on the map. Move around to place the marker and then select an angle to save that location. You can assign an icon and give a name. Let's save another location. You can click Bookmarks to delete it or send the goal directly. You can see navigation feedback like path, elapsed time, estimated time remaining, distance to go. You can also cancel nav goal here. You can directly pass a goal from the map by selecting Send Goal. For mission planning mode, click on Mission Mode and wait for the app to fetch all available topics, services, and actions on the robot. On the right side, you can select Add Mission Item. We have options like Go to Position, Wait for Time, Publish Message on Topic, Call Service, Send Action Goal, and Capture Image. Let's plan a mission where the robot undocks, goes to a position, waits 5 seconds, captures an image, then returns to the home position and docks again. Let's find what available actions there are to dock and undock the robot for the planner. First, select Action Item and select Undock from the available list. Leave Wait for Result enabled to wait until undock is complete before going to the next mission item. The goal data to send is empty for undock. Let's check another action to see the available goal data. It automatically fetches the message structure and creates a form dynamically. Let's change back to undock. Next, select Go to Position. Select from the map by long press and move, and select an angle to add that pose. We can slide up and down to rearrange items or slide left to delete that mission item. Now add Go to Position of available bookmarks. Next, add Wait for Time. By default, it selects 5 seconds. Click again and select Time. Next, add Capture Image. Next, select Go to Position. Finally, add Action for Dock with Wait for Result enabled. You can save this mission for reuse. It will be saved only for this map. Then slide right to start the mission. As you can see, the mission is started and the undock action is active. Next item in mission is executing to go to position and shows feedback like distance remaining. It is waiting for 5 seconds, captures the image, going to the home position, and the dock action is called. Mission completed. Click on Stop Navigation. Wait for at least 60 seconds for all navigation nodes to completely close, as it depends on other factors. Then disconnect from the robot. On the left side panel, you can see recent robots. Slide left on any robot to delete that robot, or you can add a new robot from the right side.